What we will do in this video is we will compare the three sorting algorithms that we have discussed in our previous video, such as the insertion, the bubble, and the selection. Okay, so to start, let's open our Visual Studio and compare each algorithm. Before we go directly in comparing our sorting algorithms, let's have a short review about the definition of our seed collection class. If you can still remember our seed collection class in our previous videos, such as in bubble sort, selection, and insertion sort, we have this definition of our seed collection class. So, but I made some changes. So now we have only one private variable, that is our array, and inside of our constructor, we only have one initialization, that is initializing the size of our array, and then we have a new method, the refill method, which generates a randomized numbers and then placing all those numbers inside of our array. And then the definition of our bubble sort, the definition of our insertion sort method, and then lastly, the definition of our selection sort method. So what we will do is to identify which is fastest among these three sorting algorithms. So we will use what we call stopwatch, a class that contains the elapsed time, and we will use those methods inside of our stopwatch class so that we'll be able to identify which sorting algorithm has the best performance in terms of speed. So to start, let's add an import statement here. So let's write here using system.diagnostic. So the system.diagnostics contains the namespace for our stopwatch. And then after adding the diagnostics import statement, let's go back to the definition of our sorting algorithms. Let's start with our bubble sort. Let's write here stopwatch SW is equals to new stopwatch. We will initiate our stopwatch to start the timer, and then it will give us the elapsed time at the end of the execution of our bubble sort. Then let's write here elapsed time SW dot elapsed time or elapse. So elapse will only work if we will stop our stopwatch. So at this point, at this line, we will write here stop. Okay, so that's it. And then we will do this for the rest of the sorting algorithms. On this side, we will do the same thing. Stopwatch SW is equals to new stopwatch, and then at this line, we'll add here SW stop, but we forgot to start our stopwatch. So at this line, we will write here SW dot start, and then we will add the console that write line, and then the elapsed time SW dot elapsed time. Okay, and then for our last sorting algorithm, stopwatch SW equals to new stopwatch SW dot start, then at the bottom SW dot stop, and then as the console dot write line, then SW dot elapse. Okay, there you go. So I guess we're done. For our selection sort, we have already added our stopwatch. And then for our insertion, we also added our stopwatch. And last, for our bubble sort, we have already included our stopwatch. Okay, so the next thing that we will do is we'll create an object out of seed collection class. So at this line, I have already created an object called DS for dataset. So we created a C collection. The name is DS, and it will contain 20 elements of numbers. Okay, so this time we will call the SW.refill. SW, oh, I'm sorry, it should be DS. DS.refill, so that we have a random numbers inside of our C collection object, and then followed by DS.display items, and then we will inform our user that this is an unsorted items. So we'll write here unsorted. Okay. Then after that, we will now try to sort these items by calling the ds.bubblesort version 2. Okay. And then again, let's write here ds.display items. Okay, so let's discuss this. We fill our ds with random numbers. Then we display the unsorted text just to mark that the displayed items is unsorted, and then we call the bubble sort, and then we display again the items. So this time the displayed items are already sorted. Okay, so let's give it a try. So let's save the changes, and then let's start running application. Okay, so the unsorted is these numbers, and then bubble sort elapsed time is 68 milliseconds, 0.000068 milliseconds. Okay, so this is now the sorted items. Okay, there you go. And then let's do this for the rest of the sorting algorithms. Okay, so to continue, let's just add space here so we can have a good separation between the unsorted and sorted. Okay, there you go. And then we will copy and paste this. And then at this line, we will rename this to insertion sort. Then again, copy this and then paste this at the bottom. And then we will rename this into selection sort. Okay. So what we did here is that we have three groups of sorting. So they sorted the elements of a data set differently. So this first group has different items from this group and from this group. From there, we will be able to identify and see who has the fastest sorting algorithm. Okay, so let's give this a try. Okay, from the 20 elements that we gave to our C collection object, our bubble sort was able to sort it in 0.000080 milliseconds. And this is the result. And then for our insertion sort, from the 20 elements, it gave us a result of 0.000036 milliseconds. And for our selection sort, it gave us 0.0000031 milliseconds. So as of now, the fastest sorting algorithm, as you can see, based from the elapsed time, is the selection sort. But whenever you do testing, which is best or which is fastest, you have to test it several times, not only once. Let's say we test this 5 times. So after getting the result from those tests, we get the average, and then that's the time you decide which is the fastest based from the average out of the 5 tests you made. Okay, let's have a test again if we can still, if the selection sort is still the best and fastest sorting algorithm. Let's run it again one more time. Okay, so this time insertion sort has the fastest. It has 0.00023. Okay, test it again. So this time insertion sort is still the fastest. And then for the fourth time, still insertion sort. And then for the fifth time, then it's still insertion sort. Okay, let's change the size of our data set. From 20, let's turn it to 100. The unsorted for bubble sort, the result of sorting using bubble sort, 0.0000694, and then again unsorted items for insertion sort, and it gave us the 0.0000329, and then selection sort gave us the result of 0.0000390. And still the fastest is the insertion sort. So you have to do this, let's say 5 times or more, and then you get the average, and then that's the time you decide which algorithm is the fastest based on the result of their average. Okay, so that's all for this video, and I hope that you have learned something in identifying the fastest sorting algorithm. Okay, see you in the next lectures.